Good afternoon, folks. So what we're going to be doing today is the topic of road geometry, and as you can see we've actually got 4 separate questions on the sheet. We're going to be working through each of them individually. They change ever so slightly on each one, okay, getting probably harder as we go along. And this is very much an introductory video into earthworks, okay, which is whereby we're kind of using real life scenarios of a road that is going through land, and we have to basically look at the topography of the land to help us do either a fill or a cut. This video here is all about fills, otherwise known as embankments, and in the next video that you will see there's going to be one in relation to cuts. Okay, so fills and cuts. In this one it's all about fills. So what I'm going to do now is I'm going to scan to the very first question here. So for question 1 it says the map shows ground contours at 10 meter vertical intervals. Okay, so we can see the distance between our contours, 10 to 20 is 10 meters. It says AB is the center line of a proposed roadway which is level at an altitude of 60 meters. Okay, so AB is the center line of a road that is going to be level at 60 meters. That means the road is 60 meters high. Okay, so that road there, I would always write in this level at 60 meters. Okay, so therefore anywhere along the road is 60 meters high. And then it says using side slopes of 1:1 for our embankments, otherwise known as our fills, our fill ratio is 1:1, so 1:1. Complete the earthworks on the southern side of the road necessary to accommodate the roadway. Okay, so for this roadway to be stable, we have to basically use a fill ratio, because, and the reason we're using a fill, and I'll explain this, is because the road has a height of 60 meters high. We can see that the land around it, at some points it is at 60, but everywhere else it's 50, 40, 30, 20, 10. So the land around it is actually a lot lower than the height of the actual road. Therefore, to actually shore up that road and make it safe, what we have to do is we have to basically stick in a load of earthworks, okay, and dirt, okay, to make the road nice and safe. Okay, so you can see down here, it's obviously the land is going downwards, where it's at its highest point here, it's going downwards into kind of like a little valley here. Okay, what we're going to do is have to fill up that land. So essentially, if we just look over here, our scale is 1:1000. So using that scale, we kind of have to work out that little magic number that we have done in previous videos. So that means 1 millimeter on our sheet is equal to 1000 millimeters in reality. 1 millimeter equals 1 meter. Okay, so the distance between our contour lines is 10 meters. So what I have to work up to is, if 1000 millimeters equals 1 meter, I have to work up to 10,000 millimeters, which would obviously equal 10 meters. So what did I multiply this to make this? I multiplied it by 10. Okay, so if I multiplied that by 10 to make this, therefore I also have to multiply what's on my sheet by 10. So therefore 10 millimeters on my sheet is equal to 10,000 millimeters, or 10 meters in reality. Okay, so that's kind of like the little magic number there. Now essentially what it is, and I've just done a little kind of like quick sketch down here. Our fill ratio is 1:1. Okay, here's our little car, there's our road, it's at a height of 60 meters. Okay, just put in a little 60 there, and essentially the land underneath it is way lower. Okay, so we need to make that safe. Okay, and how we do that is we're going to apply fill ratio. Our fill ratio is 1:1. Okay, we can see here what this triangle is here essentially is, for every 1 meter I travel down, so if this was 60, 1 meter down would be 59. Okay, I also have to travel out 1 meter from the road. And obviously in this view here we're looking down in a bird's eye view, a plan view, so we can't see how far it travels down, but we can see how far it travels out. Okay, but what we have to do is we have to apply that magic number. Okay, so for our fill ratio, 10 by the fill ratio is 1. That means essentially for every 10 times 1 is 1 meter down. For every 10 meters down I travel, I'm also going to travel out 10 meters as well from the side of the road. Okay, so what that's actually going to mean is, if I was just to draw in a triangle there, okay, for every 10 meters I travel down, I'm also going to travel out 10 meters. Okay, likewise if I was to go down another 10, okay, up to here. Now it's not a triangle a second, but you'll see what I mean in a second. Here's where the other triangle is going to go, because what I've done is I've travelled down another 10, but I've gone out 2 tenths. So that means I'm down 20 meters and I'm also out 20 meters. And likewise again if I was to go down again. And basically what we're doing is, instead of there obviously being a drop off, what we're doing is we're making a gradual slope, okay, which is actually supporting the road. And that is the idea behind it, okay. Now how do we represent that on our sheet? Okay, so what we actually have to do is, we're going to measure out, they said they only want us to complete the earthworks necessary on the southern side of the road. So what we're going to do is, if the road is level at 60 here, okay, what that essentially means is, we can't obviously measure out or measure down 10 meters because we're looking in a bird's eye view, but we can measure out 10 meters. And 10 meters equates to 10 millimeters in our sheet. So from the side of the road, starting at 9 there, I'm going to measure out in increments of 10. So if that's 60 there, this one will be 50, 40, 30, 20, and 10. Okay? So 50, 40, 30, 20, and 10. What I'm going to do is I'm going to plot in my contour lines essentially, okay? It's essentially this point right here. If that was at 60, this is going to be at 50 high, okay? So I'm drawing my contour line going across. Likewise with the 40, the 30, 20, and then 10. Okay, now you'll see in another video in a minute I could have kept that a lot neater, okay, but you can see the contour lines there. So essentially what I have to do is I have to plot where the 60 contour line passes through 60 height. So the 60 contour line is actually going to pass through and it's going to meet right at the corner of the road here. Okay, I have to look for the 51. So there's the 50 contour line passing through here, which will be where my fill triangle is. And then likewise with the 40, the 30, 20, and the 10. And now you can see the 10 actually passes through at 2 points. Okay, I'm also going to have to extend across the 20. Okay, and I can see 20 is there, and I'd imagine then the 30 will be somewhere out here like that. So what I'm going to do is I'm going to quickly sketch in that. Okay, so there we have it. That there is the earthworks necessary to shore up the road, where essentially we're after filling in a load of kind of earthworks to make the road nice and safe. Now, how you identify that that is a fill is essentially, we use this thing called tadpoling. And if you imagine, okay, because we're actually shoring up the road here where we're filling up to the road, if you put a ball here, it would roll down the hill. Okay, so essentially the ball goes to the side of the road, ball there, put another one here, and another one, and what we do is we do this little tail like that, and essentially what that means is the ball will roll down the hill. Okay, roll down the hill like that. Therefore that is for a fill. Okay, so what we're going to do now, guys, that is the first question complete there, okay, where we did the earthworks necessary on the southern side of the road. This time I'm going to do it again, okay, on the second question, only this time I'll only plot in the exact points rather than doing the lines the whole way across, and you'll see it looks a little bit neater. Okay, so I'll move on to that one there now. So for question 2, guys, it says the map shows ground contours at 5 meter vertical intervals. Okay, so last time it was 10, this time it's 5. AB is the central line of a proposed roadway which is level at an altitude of 55. Okay, so I'm just going to say roadway is level at 55 meters. Okay, it says then using side slopes of 1:1, so 1:1 for our embankments, so that's our fill ratio which I've written in over here, 1:1, embankments otherwise known as fills, complete the earthworks necessary to accommodate the roadway. Okay, so you can see here the roadway is in the middle, so we're actually going to have to do both sides, the north and the south side of our page. Okay, so this is what we're going to do. Right, first of all, working out our scale. So we can see our scale is 1:1000 once again, okay, but this time the distance between our contours is 5 meters, okay, so 5 meters is 5000 millimeters. So what did I multiply 1000, which was my scale, by to make 5000? I multiplied it by 5. Okay, therefore I have to also multiply 5 times 1. So therefore 5 millimeters on my sheet is equal to 5,000 millimeters, or 5 meters in reality. So 5 is kind of our magic number there. Now, I'm going to use that with our fill ratio, okay? So like I explained in the previous question, for every 1 meter I travel down, I'm also going to travel out 1 meter. But on our sheet, we're going to apply the 5 to that. So 5 times 1, therefore for every 5 meters I travel down, I'm also going to travel out 5 meters, 5 times 1 as well. Okay, and that's kind of the one we're going to use, obviously, to kind of plot our contour lines. Okay, so if our road is level at 55, what I'm going to do is I'm going to look at the land around it, and I can see that the land is all lower. That's why we're doing embankments here, 25, 30, 35, all the way on. Okay, first of all, I would always identify maybe if there's anywhere where the road is level, okay, with the land, and we can see we have a 55 contour here on the north side of the road, and here on the south side of the road. Okay, so that's where the land is as high as the road, okay, whereas everywhere else it's a little bit lower. So what we're going to do is I'm going to measure up the distances, and I'll start with the north side of the road, and this time I'm going to be measuring up in 5. Okay, so just put my 7 on it there. So if the road is level at 55, I'm moving away from the road, so it's going to get lower. So that'll be 50, 45, 40, 35, 30, 25. I'll do the same with the southern side of the road. 50, 45, 40, 35, 30, 25. Okay, might be hard to see them there, but go back over them. Okay, and essentially all those marks will actually have a height, okay? So if the road was 55 here, then the next one would be 50, and I'll just do every second one from here now, 40 and 30, okay? Likewise, 55 here, then we have 50, 40 and 30, okay? So you can see 30, 40, 50, then there's 55, and obviously the ones in between 50 to 40, there's 45, 35 and 25. Okay, so it's always going to go downwards when we're moving, when we're doing fills. Okay, so what I'm going to do now is I'm going to plot the points. Okay, so where 51 is, what I'm going to do is I'm going to look for the 50 contour, and like I said in the last question I did, I drew the lines the whole way across. This time I'm just going to use that as a guide, okay, and make a little mark on the 50s. The next one is at 45, so I'm just seeing where it's going to pass through. Next one's at 40. Then we have 35, and then we have 30. Someone's meeting right there, and I'm going to assume, we don't see it, but I'm going to assume that this one is 25. Okay, so likewise I'm going to do it on the north side of the road, so I'll do the 50, then the 45, 40, 35, 30, and finally 25. Okay, and what you can see is I've essentially marked all the points for my earthworks, so I'm quickly going to sketch in that curve as well. There you can see we have completed the earthworks necessary on both the northern side of the road and the southern side of the road. And as you can see at the end, I just quickly sketched in my tadpoles, where the ball is at the side of the road and it rolls away from the road. On the opposite side then the ball will be here and it rolls away on this direction. Okay, so that question was a little bit different in the sense that we have to do both sides of the road. Okay, and also we had a different kind of distance between our contours, okay, which obviously I suppose changed depending on our fill ratio, changed the distances that we have to travel up, okay. So once you can kind of sort out this stuff here to start, this bit inside in here isn't too tricky. I also then obviously just showed you a little bit of a neater way then where I just marked based on the kind of contour heights here as well. I marked the points rather than drawing the lines the whole way across. Sometimes if you can follow that, it helps keep it a little bit neater. Okay, so what we're going to do now is we're going to move on to question 3 at the bottom left of the page. So for question 3, it says the map shows ground contours at 5 metre vertical intervals, so 65 to 70, the gap between them is 5. AB is the centre line of a proposed roadway which is level at an altitude of 75. Okay, so level at 75 metres. Okay, and then it says using side slopes of 1 in 2 for the embankments. Okay, so that's a little bit different from the other two questions. Okay, the fill ratio is 1:2. Complete the earthworks necessary to accommodate the roadway. Okay, so first of all, let's work out our scale. It's 1:1000. So 1 millimetre on my sheet is equates to 1000 millimetres in reality, or 1 metre. We know the distance between our contours is 5, 65 to 70. So 5 metres would be 5000 millimetres. Okay, what did I multiply this by to get this? I multiplied it by 5. Simple maths. So if I multiplied that in reality to make up 5 metres, I also need to multiply what's on my sheet. So 5 times 1 is 5. 5 is kind of our magic number there. We're going to use that with our fill ratio. Okay, now our fill ratio this time is 1:2. Okay, so our slope is kind of changed for what they want us to make. Alright, that means for every 1 metre I travel down from the side of the road, I'm going to travel out 2 metres. Okay, so we multiply the 5 by them. So 5 times 1, okay, so you see I have a blank triangle down here, roughly the same shape. 5 times 1 would be 5. That means for every 5 metres I travel down, I'm going to travel out 5 times 2, which would be 10. So 1:2, that is the same ratio of 1:2. Okay, therefore, the distance, then we always take the one where we're using going outwards. The distance I'm going to travel out is in increments of 10 millimetres. Okay, that's the distance I'm going to travel out from the side of the road, because my ratio, my fill ratio, is what actually dictates it. So the road is at 75, and I can see that every bit of land, there's no part of the land, because we can see here 65, 70, 70, 65, no part of the land is actually at the same height of the road. So if the road is at 75 here, if I travel down in increments of 10, okay, marking down 10s there, that's 10, so that would be at 70, another 10, be at 65, 60, 55, and finally 50. Okay, so these marks here, we've got, 70, 65, 60, 55, and 50. And likewise, do it on the other side of the road, mark up in 10s. Just have room for 2 here. So there's my 75 to 70 to 65. Okay, so what I'm going to do now is I'm going to plot in those contour lines. So where the 70 is, this time I'll actually do the lines. 65, and I'll just show you, I'll guide them out. 60, I'll do them in the whole way. Then we have 55, I kind of see where I just need it to. Then I have the 50, okay, so that's the southern side. The north side of the road, 70, and 65. Okay, so plot our points. So I'll do the north side of the road. So this one's at 65 and 65. Then we hit 70 and 70, and here, so 65, 65, because I can see the contours going around like this. 70, 70, 60, 55, 50. I'd imagine 45 would be somewhere down there then. Okay, so I'm going to quickly sketch in that. Okay, there we have it. That is the earthworks completed on both the north and the southern side of the road. And as you can see in this one now, there was no point where the earthworks were actually going up to the height of the road. So basically, the land all around the road, every bit of it was actually lower than the road. There was no point where the land was the exact same height of 75 meters as the road. Okay, the closest it was 17 meters on both sides. Okay. So that's that one done there, guys. The slight difference in that one was with the difference between 5 meters in our contours, but our fill ratio was actually different there in that one. Okay, so a little bit to be aware of there. Okay, using the 5 and then multiplying it by the 1 and the 2, and the one we used was 10 meters traveling out. Okay, so what we're going to do now is we're going to move on to the last question on this page, question 4. Alright. So the last question on this page, guys, it says the map shows ground contours at 5 meter vertical intervals, so the distance between them, 80 to 75, is 5. AB is the central line of a proposed roadway which is level at an altitude of 80, so level at 80 meters. Okay, and then it says using side slopes of 1 in 1.5 for our embankment, so our fill ratio is 1 is to 1.5. Okay. Complete the earthworks necessary to accommodate the roadway, and our scale is 1 is to 1000. Okay, so as always, we'll work out our scale first. So 1 millimeter on my sheet is 1000 millimeters in reality, or 1 meter, and the distance between my contours is 5, so I have to work up to 5 meters. I know 5 meters equals 5000 millimeters. Okay, is equal to 5000 millimeters. So what did I multiply this by? I multiplied it by 5. So 5 times 1 is also 5. Okay, therefore 5 millimeters on my sheet equals 5000 millimeters in reality. So that 5 there is going to be like number that's going to help us. Now we're going to apply that to our fill ratio. Okay, so our fill ratio in this case, so far we've had 1 is to 1 and 1 is to 2. This time we have a 1 is to 1.5. That means for every meter I travel down, I'm going to travel out a meter and a half, 1.5 meters out. So I have to apply the 5 to that. So 5 times 1. For every 5 meters I travel down, I'm going to have to travel out 5 times 1.5, which equates to 7.5. Okay? And what that essentially means is, for every 5 millimeters on my sheet I travel down, I'm going to travel out 7.5 millimeters. Okay? So that's the one we're going to use there. That's 7.5. Right? So if our road is at 80, okay, I'm going to put in the measurements on this side. So if our road is at 80, okay, first of all we're going to find, is there any parts of the road that are at 80? Yeah, or the contours. So I've got an 80 contour here. So that's where the road is the same height as the land. Everywhere else it's actually lower, and the lowest it goes down to is 55. So what I'm actually going to do is measuring down in increments of 7.5. So what you do is, obviously we don't have 0.5 increments on our set square. You guesstimate or estimate the best distance, so right in between 7 and 8. So between 7 and 8 there. So there's 1, then it would be 15. So that would be 75, 70, then I go 7.5 again, and then 7.5 again. I might have to do one more, I think. So 75, 70, 65, 60, 55 I think it's, yeah, that's the lowest. And I'll do the exact same going upwards as well. So 7.5, 5 to 7.5. I might only have to do one more here, I think. Yeah. Okay, so plotting my heights then. My contour heights: 75, 70, 65, 60, down to 55. Likewise here, if this was 80, 75, no, it's hard to see there, sorry, probably did it on the wrong side, 70, and then 65. Okay, so what I'm going to do now is plot across those contour lines. So just do the 75 one. 70, 65, I'm sure I could do this a bit neater, 60, and finally 55. Okay, you can just about see those on the screen. So that's 75, 70, 65. I'm not sure if that one's going to be needed. Right, so we'll plot our points. So with 80 there, 75 down to 70, 65, 60, 55, 55. Chances are I'm not even looking over here, but I can kind of tell. So there's the 55, yeah. Then we're going back up to 60, then up to 65. As you can see, the contour line is going the whole way around. Then we're on to 70, and then 75, and I actually missed out on one here. The 80 is meeting at the road over on this side again. So likewise on the north side, there's the 80. So I'd imagine then this is the 75 contour, yeah. And then this is going to be the 70, yeah. There we go. So I actually didn't need the 65 one. Okay, so I'll just put in those now. So there we have it, guys. That there is the fourth question completed. Hope you found that video helpful, guys. That was very much based, an introductory video based on the earthworks and the embankments, otherwise known as fills. Okay, quite useful and helpful there in working out the scale once again, and then applying it to our fill ratio, which is probably the most important part in understanding that. So hope you found that helpful, guys. That's that video done.